hand in hand, right? So exactly in different machine translation, information retrieval, NLP, they may make a combination such a way that whatever we want, whatever users wants, they get it in terms of the same language, monolingual or bilingual or multilingual. So she will be taking the challenges being faced by low resource language. She'll be taking Hindi only. And how do we get the connection between the edges? Like in graph, we have nodes and edges. How do we have the connection between two nodes through an edge? That she'll be explaining, and it's going to be very important and very helpful lecture for your future research, right? She will be covering the resource available for the low resource languages, and the institutions who are working, what are the Bhashini she is doing in terms of 22 Indian scheduled languages and other things also. So over to you, Manju. You can start.
Yes, ma'am. Thank you so much for introducing me. Thank you. Sorry, I think net was disconnected initially. No problem. Am I audible, ma'am, now?
Yes, Dr. Manju, it's okay.
Yes,
Please,
I'm just sharing my screen again.
Please.
Yes, I think now it is visible perfectly, and I'm also audible. All right. I'm sure I'm audible and my screen is visible.
Yes, perfect.
All right. Introduced me. Today I will be taking a session on semantic graph-based information retrieval for low resource languages. And as ma'am told that I will be specially covering Hindi information retrieval. This will be today's session's agenda. Firstly, I'll be covering information retrieval, how it evolves through multiple generation, because it is not a new concept. Since the computers came into picture, information retrieval also, you can imagine that retrieving the information was also came. But the methods of retrieval has definitely changed. So we will be covering those things, that how it has evolved. Then challenges with information retrieval, specific reference with Hindi information retrieval. Then what is the need of semantic IR? Why we talk about semantic IR? Semantic graph modeling. This is one of the way using that semantically informations can be retrieved. So semantic graph is one of the means that. Semantic graph IR architecture, semantic graph ranking, how the documents are ranked by making use of semantic graphs. Then evaluation matrix, evaluations of the results, how the results ranked by the semantic graphs are evaluated. Then we will be switching to neural IR, because every concept or every kind of architecture has some limitations. So the semantic graph as well. So to overcome that limitations, how neural IR concept introduced and how it overcomes from those limitations. Then we will be covering neuro-symbolic IR and graph neural networks as well. Then at last, we will be discussing future research directions in this particular topic. So very firstly, how the information retrieval is evolved. So we divided information retrieval in 4 different generations. Starting from the past, from 1950s to 1970s, where the Boolean retrieval was possible, means the information was retrieved through Boolean parameters, Boolean logic parameters like and or not. For example, if somebody wants to
Professor Manju, sorry to
search,
interrupt. Are
yes,
you
ma'am.
moving your slides?
No,
We are at the first slide right now.
yes, ma'am. I'm moving. I'm moving the slide.
No.
I'm on evolutions in IR
No.
slide.
We are at the first title
It is
slide.
not visible.
No.
All right. Let me once again do it.
You have to do slideshow. Slideshow.
I have already done that. I wasn't
You stop
using
sharing and do
slideshow.
it again. You take full screen.
All right.
Stop sharing.
Just a
Yeah.
moment, ma'am.
Now share it.
Okay.
So instead of taking windows, you take the full screen sharing.
Yes, entire
Yeah.
screen. I took entire screen and then I shared. Just a moment. I share and now is it visible? Screen is visible?
Do it full screen, please.
Just a moment. Uh,
Yes.
is this visible?
Yes. Now it's perfect.
Now
Now it's moving.
is it also moving?
Yeah.
All right,
Do it
fine.
from start. Do it from start now. Yes. Do it from this place because I
All
don't
right.
see it. Yeah.
From session roadmaps.
Yes.
All right. So in this session, we will be covering information retrieval, how the information retrieval concept evolved during these years. Then challenges, what are the kind of challenges information retrieval faces with a specific reference to Hindi. Then to overcome those challenges, how semantic IR will be helping. We will discuss that. Semantic graph modeling. Yes, semantic IR can be done with different ways. One of the way is by using or by creating semantic graphs. So we will be discussing how semantic graph information retrieval architecture works. Then ranking. Once the document is constructed using semantic graphs, how the documents retrieved are ranked, then evaluation of the results, performance evaluation, the matrices we use. The neural IR means the combined hybrid structure of semantic graph in combining with neural networks. Then we will also discuss neural symbolic IR and GNN, graph neural networks. So at last, we will be concluding by discussing research directions for future research. Now, first of all, we will be discussing evolution in information retrieval. So the concept came into picture earlier in 1950s. So from 1950s to 1970s, the Boolean retrieval, the concept of Boolean retrieval was used for information retrieval. Boolean retrieval relies on and or not kind of logical operators, wherein the query is given, for example, the query is like cat and dogs. Means in this case, if the user has given a query cat and dogs, then all the documents which are exactly having cat and dogs will reach. If none is having cat and dogs, means none. In that case, none of the document will be retrieved, even if any single document is having either cat or dog, but it will not be retrieved because the whole phrase will be taken. If the whole phrase is there, then only the document will be taken, retrieved, otherwise not. So this was a limitation with Boolean retrieval. Then from 1980s to 1990s, what happens, the vector space models, statistical and vector space models came into picture, wherein in case of Boolean retrieval, what happens that there was a limitation of it was not counting about the frequency, that how many times that particular phrase is appearing into the documents, into the retrieved documents. So definitely it deteriorates the performance, because in any document, if the frequency of the searching phrase is more, then definitely the document is also more relevant to that. So to overcome from that limitation, vector space models and some more statistical based retrieval models came into picture, wherein the document as well as the query, user's query, both were represented in form of vectors, and TF-IDF weighting is provided to the document terms, and as per the TF-IDF weighting, the documents are ranked. So this was the model appeared, and it overcome from the limitations from the Boolean retrieval. Then in 2010, the web era came into picture, overcoming the limitations of a vector space model. And the major vector space model's limitation was it always matches the concept, matches the term lexicographically. Means if cat is given, the cat is searched. If suppose woman is given, woman will be searched, not the girl. So what is happening in this? Only the lexicographical similar terms will be retrieved, or the documents which are having those terms, that will be retrieved. There is no concept of semantics. So in case of web era, link analysis and modern IR, which is making use of semantics, wherein first time the semantics has introduced, this was the era. So in case of link analysis, when there are, it was specifically used in web-based information retrievals, wherein one particular web page is retrieved if that is also linked by with another web pages, or another web pages are also referring. So the more web pages, more relevance, more. Similarly, LSI concept, that is latent semantic similarities, wherein the semantics means synonyms. Only the semantic relationship which considered in LSI, that was the synonyms were considered. Means suppose, as I told you, that woman is there. Sometimes woman is also called as girl. In many times it happens. So they are also kind of a synonym there. So this particular semantic relationship, due to this particular semantic relationship, the documents which are having woman as well as the girl, both can be retrieved, and they are semantically related. In presently, the present era and the future is also, because why future? Because there is a lot of work needs to be done in the work which is presently going on. So, apart from taking the semantic relations, more and more semantic relations, neural networks also come into picture, and they are also combined with semantic graphs, and hybrid models are prepared to overcome many things. For example, context matching. In case of semantic relations, there is no matching of context. They are not talking about context. So come from that limitation, the concept of neural network based models came into picture, and also they work on embeddings, word embeddings, sentence embeddings. In that, we will discuss it later on in detail. So that comes into picture, and now in this era, a lot of work has already done, and many possibilities are here also. And further, the graph neural network also came into picture. We will also be discussing the architecture of that into detail in this session only. So this was the evolution, how the information retrieval evolved through multiple generations. Now we are just comparing that these four generations Boolean means only logical operators were matched. We already discussed, but in a single glance we can also talk about it statistically. The second generation was and TF-IDF. Mathematical ranking, how important the word is, means in case of Boolean, only the word matching was done. If exact phrase is there, then the document will be retrieved. Otherwise, no. In a statistical case, not only the document will be retrieved, but it will also giving the rank kind of thing to the documents retrieved. In case of web, the third generation, do others trust, means whatever information is retrieved, that is also trusted by other pages as well, because it was based on web information retrieval. Then lastly, neural network, what do you actually mean? Means it is also considering the context, not the word only, not the semantics only, but also the context as well. Now, what are the challenges we are facing for information retrieval, because information retrieval is completely associated with natural language processing that can be either English, Hindi, or any Indian language or foreign language. So almost all kind of languages facing these kind of challenges. For example, synonymy problem. One word can be can one particular thing can be said by using many words, many different words, and these many words are also conveying the same meaning. So that is a synonym problem. For example, in case of a sentence, we are saying school, vidyalay, for example, shikshan sansthan, shiksha ka kendra. All these are basically conveying the same meaning but synonym. So are we able to algorithms are able to address these kind of problems? And polysyncretic means one particular word can have multiple meanings in different contexts. For example, bank can be used as a river for the context, in context with the river, as well as bank for the financial institutions as well. So the context, if some algorithm is also addressing the context, it is fine. But if it is not considering that, then the documents retrieved or the efficiency of that particular retrieval is not correct. Then vocabulary mismatch for different words used for the same means. For example, there is a term physician. So if you're matching physician with and matching with the documents that are having only physician, then it is not fine. But if there is a document having doctor as well, and if your retrieval algorithm is not taking it as a relevant document, then it is means it is not taking the related documents as well. So again, this vocabulary mismatch is a problem. Context understanding, as I already discussed, that in different context, the word meaning can change. For example, in case of bank, low resource languages, yeah, definitely. As far as English is concerned, a lot of research has already done. A lot of research resources are already there. But in case of low resource languages, means for in case of Indian languages, many regional languages are still uh, under the research work. They are not having good data resources wherein the research can be done, because the data set and lack of data sets, annotated data sets, many different things which are needed, that is not available. So that is also a challenge. Until unless you are not having resources, you cannot create model, you cannot train the model. And once you are not able to train the model, you cannot make the things better. So these are the common challenges with the IR. And what are the specific challenges we are having Hindi and other low resource languages with special reference to Indian languages? For example, rich morphology. For example, in case of a teacher, for a particular teacher, there are multiple words like shiksha, shikshak, shikshika, shikshan. All these words are related. So one word can create multiple variations. So are the information retrieval algorithms really prepared for to address such kind of variations? Free word orders, like for example, Ram ne Sita ko kitab di or Sita ko Ram ne kitab di, both are conveying the same meaning, but are retrieval to find all these things with all these variations, but conveying the same meaning. So these are the challenges still we are having. Vocabulary variation. I already told, already taken the example of school, vidyalay, shikshan sansthan. Code mix language. Yes, आज school में exam है. It is having Hindi plus. If I create the semantic graph or any tool I use, whether that particular tool is capable to handle both the languages at the same time. So that is the challenge again. Limited annotated data sets in case of Indian languages, including Hindi, very limited. If I go with some kind of application, NLP based application, I find that there are very limited and most of the time we need to create the data set for our own research work. Scarcity of linguistic resources compared to English, like for English is very rich, and not ontologies but the domain-based ontologies are very much available, but it is not so for the Indian languages. Similarly, for the knowledge graphs, large semantic corpora, etc. Named entity variations. For example, any named entity, for example, Mumbai, Bombay, Mumbai, all are conveying the same meanings, but with multiple spellings. Systems must recognize them as the same entity because are indicating same term. So to address the few things um, we have taken into our these challenges: synonymy, polysemy, vocabulary mismatch, context understanding, low resource languages. To address all these kind of problems, we need to have a rich semantic based information retrieval systems which addresses all these semantic variations, all this semantic relationship. So overcoming limitations of keyword based retrieval, very first thing which semantic IR will be addressing, that it will not rely on lexicographical similarity. Rather, it will also take care of semantic relationships, understanding the user's intent, what user want to say, what in which particular sense user is using a particular term, handling synonyms and polysemy. Synonyms and polysemy we discussed, improving search in low resource languages, because if we are having a resource, if we are able to create semantic resource, then definitely it will improve the search condition of low resource languages as well. Enabling concept based retrieval. Yes, when we are able to find synonyms, polysemy, and definitely we are trying to combine the similar concept in a row. Supporting advanced AI applications, because NLP is a much larger domain. So many applications based on NLP based NLP domain, then we are able to develop many applications if we address this semantic AI, IR. Improving precision and recall. What is precision and recall? Precision and recall are evaluation matrices, performance evaluation matrices. We will discuss it later on in a detail. But as of now, these are evaluation matrices, and if we are able to involve semantic IR in a enhanced way, then definitely we will be having a good precision as well as recall. Improving precision and recall, again, it is taking in how the semantic IR is basically enhancing this thing. So through the synonym handling, it will be improving the recall. Recall is basically, it is all about that. Suppose there are 100 documents, and out of 100 documents, 70 documents are relevant, and your system, your information retrieval system, is able to find 50 out of 70, means that is the recall of that. As far as precision is, means overall out of 100, if 50 is retrieved, that is what we call precision. Is if we use semantic based IR, it will be improving precision and recall by handling synonyms, polysemy, concept based, context understanding, and knowledge graphs. Key technologies used in semantic IR. As far as of now, we have discussed what are the semantics, what are the semantic relationships. Now, what are the different ways through which semantic information retrieval can be achieved? So one of the finest and most popularly used ways, ontologies. So ontologies are basically a kind of network, hierarchical network, where you can visualize it as a graphic in a graphical form, and where nodes are representing some concepts and the ages are representing relationships between them. Ontologies can be generalized, as well as they can be based on some kind of domain. For example, ontologies for healthcare, for agriculture, or for any other domain. WordNest is most popularly known ontology. WordNet, very firstly, WordNet was introduced by Princeton University for English language earlier than 2000, way back to earlier than in 1998, I think. And in year 2000, IIT Bombay also launched the Hindi WordNet as well. And till now, they have developed many WordNets in Indian languages as well. around 20 to 23 languages, they have developed WordNet. So WordNet is also a kind of ontology wherein many kind of semantic relationship between the terms has shown. I'll be sharing a picture of that as well. Semantic graph, WordNet is also a kind of semantic graph. Graph having nodes and edges, and the edges are representing the between nodes, semantic relationship between the nodes. That is basically the semantic graph. Knowledge graph and semantic graph both are related terms. Embedding models, wherein in embedding models, different kind of models, word embeddings, sentence embeddings, BERT, and all other models can be. Many other models are also used, and they are taking care of. They're taking semantic IR into consideration. Transformer-based semantic retrieval models are also making use of semantic IR. Now, semantic models. There are basically two terms which are related: semantic modeling and semantic graphs. So we can visualize this thing. Semantic modeling is a kind of blueprint for any semantic graph. Means if you need to create a graph, firstly you have to create a semantic model. That is the difference between a semantic model and semantic graph. Semantic graph, I already told about it, consisting of edges and having many semantic relationship, which we will be discussing one by one thoroughly here. Uh, so now here we will be considering semantic relationships in detail. So very firstly and most important semantic relationship is a relationship that is also known as hyponyme relationship. You can visualize this relationship specialization kind of thing. For example, Pal. In case of, if I take example of Hindi, Pal is a category or a class, and there can be multiple instances of that. Kela, Seb, Amrut, any other instances can be there. Similarly, for English as well, fruit is a class, then mango, banana, other fruits can be instances of this. So, what is the relationship between Phal and Aam? So, Aam is a basically Phal. Aam is a Phal. So, Aam is a specialization of Phal. Phal is a generalization. So, in semantic graph, we show this kind of relationship. Instance of Taj Mahal in Smart. Smart is a broad category, a class, where Taj Mahal is also a kind of or instance of this particular category. Part of relationship represents component or part relationship. For example, car is there, and car is having many different components like engine, other things, wheels, many other things are there. So they, whatever is part of a big system, that is sharing the relationship part of. Has part means car has an engine. That is the reverse relationship, means part of has part. Meronyme, holonyme. So has part is holonyme relationship. Synonym, already discussed about thing. One particular term can be can have multiple vocabularies like Vidyalaya, school, Pathshala, Shiksha Kendra, Shikshan Sansthan. All are conveying the same meaning. Antonym. Antonym is reverse or opposite to each other. So they are also semantically related. Related to, this is also one of the relationship, means Shikshak and Chat. You cannot visualize them apart. They are related to each other. Cause effect. Barish se baad aayegi. So Barish and Baad are cause and are sharing cause and effect relationship. Baad ko bina barish ke nahi dekha ja sakta. We cannot visualize. So Baad is always caused by the barish. Attribute of, say, for example, apple is in fruit, and its color, that is red, it is an attribute. It's if it is sweet in taste, this is also again an attribute. So attribute of relationship is also a semantic kind of relationship. Located in, Taj Mahal is located in Agra. Used for, knife is used for cutting. So these kind of relationships are not captured by any lexicographical based similarity models. They all these all kind of relationships are taken care by semantic based information retrievals. All kind of semantic based IR models, semantic models, ontology, or other knowledge graphs, semantic graphs, all they takes care of that. So semantic graphs as well. Among all these semantic relationships, we are having the most important relationships are is a synonym, part of, and related to. They are uh, most popularly used because they are most effective at the time of semantically information for semantically retrieving the information. Uh, this is a snapshot of a particular the what example we were discussing was related to fruits. So phal and aam both are sharing is a relationship, means aam is a phal. So this is a kind of semantic graph as well. So aam is a phal. Both terms are sharing the is a relationship. Aam is a specialization of phal. Similarly, if the relationship between Aam and Guda means the pulp of the mango or Aam, they are sharing the part of relationship. Similar relationship part of the Piru, that is Gutli, or we can say seed of Aam. So both the things are basically sharing part of relationship because they are part of Aam. Similarly, in pulp, inside the pulp, we are also having beej, means the gutli is there. So beej is part of Buddha, that is pulp. And similarly, beej is also known as gutli or pidu in case of Hindi. So this is a short for the only one kind of fruits relationship, how these other different terms are related to each other, semantically related to each other, what we are trying to show here. This is also a snapshot wherein we also consider different relationship. For examples, Phal is there, and in Phal we are having Lichi, and Sep, and in Aam we are having Gutli, Guda, and Chilka. So these are different type of uh, part of these sharing meronomy halonomy relationship in part of or has part relationship they are sharing. So any questions as of now, please feel free to ask. If any of the question, please feel free to ask. Otherwise, I will continue. All right. So now we will be discussing what is the importance of semantic graph-based approaches. Once a documents means if a document is there or a set of documents are there, if we are able to create, if we are able to construct a semantic graph for those documents, for set of documents, then we can have we can make a use of that particular graph for multiple applications. For example, it can be applied to several applications for text mining, such as detecting closely related concepts, discovering most dominant concepts, which generate some meaning of the text, and providing text structure in a better way. Now, what are the different applications? Semantic IR we have discussed. Semantic graphs we have discussed that what is semantic graph, what different kind of semantic relationships it can have. Now we are talking that if one semantic graph is constructed for particular set of documents, how it can be utilized, for which kind of application it can use. So semantic information retrieval is possible once the semantic graph is constructed. Then question answering systems. Yes, when you query and it provide you with a response, then if it relates your query with the document semantically, then definitely you will be having better performance in terms of the documents. Example queries Bharat ke Pradhan Mantri kaun hai, and graphs linking these particular nodes like Bharat, Narendra Modi. These are linked concept. Bharat, then Pradhan Mantri, and then Narendra Modi. So if the query is Bharat ke Pradhan Mantri kaun hai and your graph is linked to these three terms, then your information retrieval system is able to answer in this way and correctly. Knowledge graph construction extract entities and relationships from text to build structured knowledge graphs. Delhi Bharat ki Rajdhani, Delhi is capital of India. this kind of knowledge graphs can be constructed. Named entity recognition helps identify and connect entities like persons, locations, organizations. Because when the semantic graphs uh, in nodes, they represents the concepts. So different type of concepts, different types of and named entities that can be represented using the graph nodes. So Narendra Modi Delhi guy, person, who is the person here? Narendra Modi. And what is the location? That is Delhi. Both are named entities. One is the name of the person and another is conveying the name of the location. Then another application, it can be used for words and disambiguation, as in case of synonymy, polysemy and all. There is lot of ambiguity in case of NLP applications. So semantic relationships resolves ambiguities when a word has multiple meanings. Like word bank. Bank is also can convey the meaning uh, related to reverse bank as well as financial bank. So how these kind of ambiguities can be resolved by semantic relationships. Applications, further applications are text summarization. I already used semantic graphs for text summarization as well as keyword extractions as well, and had a very good performance in comparison to other models. So text summarization, semantic graphs identify most important concepts in the documents, and important nodes in the graph represent key topics for that particular summary generations. Relation extraction extract semantic relationship between entities in text. Ram ne Sita ko kitab di, Ram gave Sita. So what is the different relationship between the subject, predicate and the object? Semantic similarity measurements विद्यालय शिक्षा देता है, स्कूल शिक्षा प्रदान are they semantically similar? So you can retrieve this kind of results, this kind of answers from any semantic based graph models. So विद्यालय शिक्षा देता है and school शिक्षा प्रदान करता है. Both are basically conveying the same thing and they are semantically similar. Then coming to the machine translation, improved translation by preserving semantic relationship. Here we are talking about translating any particular text from one language to another language. So if there is a sentence in Hindi, Ram ne Sita ko phool diya. English, Ram gave Sita a flower. So constructing or translating from one language to another language, if we are able to establish this triplets relationship, subject, predicate, and logic, then we can. It will be easier for us to convert the sentence from one language to the another one. Dialogue systems, chatbots help chatbots to understand, because chatbots are completely relying on NLP, natural language processing. So help chatbots understand context and relationship between users' queries. Like Delhi ka mausam kaisa hai? System retrieves weather information for Delhi only. In that case, Delhi only. Similarly, if somebody asks for any admission query or trying to find the best colleges in Jaipur, then also chatbots will be able to answer after semantically relates the term in the query and the documents. Now, after discussing the applications, we will be discussing what are the different ways to construct semantic graphs. So one of the ways which we have already discussed about also discuss a screenshot of hull and different kind of hulls for ontologies as well. So that is lexicon and ontology based construction, one possibility. And the basic idea behind it is it uses existing linguistic resources such as WordNet or ontologies to build graphs. So for ontologies, WordNet is a wonderful tool to be used, and it is having very rich semantic relations. Process and all means process means how we are retrieving documents by finding the relationship between the query terms and the document terms only. The semantic relationships. Advantages: accurate semantic relationship, well structured in knowledge, but it has some limitation, that is limited coverage or low resource language like Hindi. Because as I already discussed that Hindi and other Indian languages are morphologically very, very rich. Means one word can have multiple variations. Multiple variations. Are we considering all kind of morphological variations? So that is the limitations. If you skip any one of the, if the semantic graph or word, the retrieval efficiency may suffer in that case. Co-occurrence-based constructions, words appearing together in text are assumed to be related. Means not only the semantic relations are considered, but also co-occurrence. If two words are co-occurring with each other many times, means they are related somewhere, like aam or phal, aam or meetha. Simple data-driven approach, because there is no semantics are considered, but co-occurrence feature is considered. Relationship meaning may not always be clear. We are just considering in this co-occurrence based construction the co-occurrence relationship, none other relationship at all. Dependency parsing based constructions, such kind of constructions are basically used for syntactic parsing or grammatical, to establish grammatical relations between the terms. Apply dependency parsers, ram, ya, the different terms are linked with each other syntactically or grammatically, captures grammatical structures and require accurate parsing models for that. Apart from that, entity relationship extraction models are there. Embedding based constructions are there, uses semantic similarity, learn from vector based embeddings. Train models like word to bird, sentence transformers connect semantically similar words. They are having this feature. All these embedding models consider semantic related terms. Captures latent semantic relationship. Synonym relationship is may be unclear in the case of embedding model. Hybrid, and why it is so, we will discuss it when we will be discussing the architecture of embedding models. Hybrid construction, modern approach that is combining both semantics as well as embeddings. So producing much richer and more accurate semantic graphs, more complex for design and implement, because computational complexity becomes higher in case of hybrid construction, because you are combining two models at a time. Although we have discussed the ontologies, ontologies is a formal and structured representation of a particular domain which defines concept, entities, and relationship between them. Hindi, Hindi WordNet is a kind of ontology which came into picture in year 2000 and developed by IIT Bombay by late Pushpak Bhattacharya sir and team. An ontology motivated by widely popular English wordnets. Yes, it is inspired by English wordnet. Ontology systemize lexical information about terms and semantic relationships between them. Open class category of words. This is open source tool as well. Hindi WordNet contains its corresponding, its glosses, and position in ontology. So synset means set of synonyms, and glosses means any narrated things, any explanation, description about those terms, and position that particular term into the ontology. This is the information provided by Hindi WordNet for each and every terms. Means if a term is there, suppose woman is a term or aurat is a term is there, all the synonyms, set of synonyms will be there. Glosses, the means gloss means narration of that particular term, including example for that, how it is used, and position in the ontology, a broad ontology of that particular term. So that is how Hindi WordNet is constructed. A screenshot is also I have pasted here, but I think it is not much visible here. Uh, yes, you can see here Hindi Shabdantra. Hindi WordNet is known as Hindi Shabdantra in Hindi. Suppose Agra is there, भारत के उत्तर प्रदेश राज्य का एक शहर, ताजमहल के कारण आगरा विश्व प्रसिद्ध है. That is a narration about that. Similarly, शहर, नगर, नगरी, city, पूरा patan, snatak. All hypernyme words are there. Sthan, jagah, sthal, pradesh, bhu, bhag, bhushit. These are basically means Agra is a sheher. Sheher is a sthan. Sthan is a bhubag. This is basically trying to show a hierarchical relationship between these terms. Then bhubag is a kshetra or ilaka. So this is how in Hindi Shabdantra or this ontology, the semantic terms are described and how they are organized into this Hindi word. Now, what are the benefits of using? Although we have taken care of the semantic graphs benefit, but again, contextually intelligent. It is more intelligent, giving more intelligent relations than the earlier lexicographical models or statistical based models. Flexible data integration, you can easily add new nodes like a new fruit or a specific variety of fruits we can easily add. Multilingual support is the diagram in our ontology diagram wherein I have shown pal, lychee, save. In that particular, multilingual supports can be there. Discovery, because the relationships are explicit, you can discover information. Yes. So these are the benefits of semantic graphs. Now, how the semantic graph can on the basis of semantic graph, how informations can be retrieved. The whole process is explained in this particular architecture. So what is happening in this here, if I start from the left side, there will be unstructured data sources, because in natural language processing, most of the time unstructured data is there, and that data can be in form of documents, PDF, Word documents, HTML, web pages, and so on. So this is the raw data here. Raw data is here. And then once this raw data is provided to this particular pipeline, document ingestion and pre-processing. In document ingestion step, the data is documents are loaded, uh, and LangChain is one of the tool through which the documents can be loaded in this graph-based model. Then text extraction and cleaning means whatever text is given into these documents, that will be pre-processed first. And how these are processed? For example, punctuation marks can be removed, the words can be broken. The non-content words, like in case of the English, is mr, is mr, in case of the yeh, weh, these are non-content words that can be removed because they will not be helping out us for creating semantic graph and further for retrieving results as well. So once the pre-process, then tokenization will be performed. In case of tokenization, what happens? The terms are individually extracted. Each and every term, after pre-processing, each and every term will be extracted. That is, this process is known as tokenization, and in Python, NLTK SPACI can be used for tokenization purposes. Text parsing, basically this is a syntactical parsing, that how the sentences are grammatically organized. In this particular component, the sentence are grammatically organized. The second component, this is showing the semantic graph constructions. Once we are done with the pre-processing, tokenization, and text parsing, now in the second step, semantic graph will be constructed. During this construction process, first of all, entities will be extracted through tools. Entities will be extracted through tools. Then relationship among these entities will be captured, will be established as per this graph. Then entities linking. Once the relationship is, then entities, and through their relationships, the linking will be established. Semantic triplet formation. For each and every sentence is having subject, predicate, and object. So this kind of relationship, this kind of formation will be established for each and every sentence in the document. Here, after extracting the entities and relationship and linkage, the linkages will be established by using the ontologies, wherein the terms are organized in form of classes and their instances, their properties. Once this is done and the semology or the semantic triplets are done, we can construct semantic uh, knowledge graph. For example, again I am taking the same example. Phal is there, and फल एक प्रकार है किसका, आम एक प्रकार है किसका, फल का. इसी तरह सेब एक प्रकार है किसका, फल का. केला एक प्रकार है किसका, तो here we can say these are the nodes, सेब, फल, आम and केला. These are the nodes. Ages एक प्रकार है, that is basically ages are showing the relationship between the nodes connected. And gun means this attributes. Gun means here simply the attributes, which is not shown here, but the color of the fruit or the taste of the fruit or anything else can be done, the size of the fruit, etc. So this is how the semantic graphs can be constructed, and what are the prior processing part uh, before considering before constructing the semantic graphs. Here I have taken that particular example. आम एक फल है. Suppose I'm giving this particular as a input document. My document is having a single sentence. आम एक फल है. आम मीठा होता है. Document ingestion. What document ingestion? What we have shown in architecture. The very first step was document ingestion. That is document and pre-processing. So here, after pre-processing of this particular sentences, the tokens which derived, that was aam, phal, and meetha. Hota and hai, these are not content words, so they are not making any sense including as a token. Entities extraction. Among these, there are two entities, aam, phal, and meetha is basically an attribute of that. Relation extraction, relation between the arm and phal is, arm is a kind of, so it's a arm ek prakar hai phal ka. So here we are extracting the relations. Semantic triplet, arm ek prakar hai phal, or the, for the second sentence, arm, swad or meetha, these triplets were derived by the semology or semantic triplet formation. Ontology mapping, these terms and the relationship between these, the, for example, class arm is coming in the class of phal, instance will be the arm, and the property will be swad. That is ontology mapping. Ontology, and what is the function of ontology mapping? So the terms will be mapped, that in which category the terms are coming under the ontology. Semantic graph construction, after this ontology mapping, we can establish the links between the terms and these entities. And document ranking, once on the basis of the semantic graph relationship, multiple documents can be retrieved by the information retrieval, and then those documents can be ranked. Semantic graph ranking. Now, the last part was the last part of that particular architecture is the ranking itself. So once the documents are retrieved, that is not sufficient at all. Which document is most related and which document is least related, and other documents are average. So how we can consider one document as an average, having average efficiency, retrieval efficiency, or one is having highly related with the query terms. So semantic graph ranking is the process of ranking documents or concept based their relevance to the query. Instead of using only keyword frequency, semantic graphs take care of concept relationships and graph connectivity. This is a snapshot of how ranking process is done. User will be providing the query. Concept will be identified in the query. Semantic graph will be created and traversed. If already constructed, or if we are making use of already constructed ontologies, then we will just traverse those ontologies. Similarity and relevance score between the query and the documents will be computed, and then the documents will be ranked. Now, for ranking purposes, what different aspects we take care of? First of all, graph connectivity. Documents connected to more relevant concepts receive higher ranking. Means if Vidyalaya is connected with Chhatra and Shiksha, if a document contains several related nodes, it definitely gets a higher score. That is how the graph is connected. That is also a ranking mechanism. Path-based ranking, shorter paths between query and document concepts indicate stronger relevance. If they are having query and document terms are having a lot of distance, then these are not considered as a related terms. Query terms are not related with the retrieved document terms. Then the third one, first was the graph connectivity based graph ranking. Second, path based, and third, and very important, that is graph based algorithms. Also the page rank based ranking, random walk algorithms, graph centrality measures, semantic similarity scoring, and documents containing similar concepts are ranked based on semantic proximity. Among all these, we will be thoroughly discussed about the graph centrality measures in this particular session. Uh, I will be considering those centrality measures in next slides. Evaluation matrices, precision, recall, I have already discussed, but again, precision measures how many retrieved documents are actually relevant. And recall is measures how many relevant documents were retrieved from all relevant documents. F1 is average of all both of these, precision and recall, and mean average precision is mapping. It evaluates ranking quality in retrieval systems. So these are some of the evaluation matrices which are used to evaluate information retrieval systems, retrieved documents performance. This is the mathematical formulation of these evaluation matrices. Now, as I told you that we will be discussing in detail the graph theoretical measures that can be applied for semantic graph and how they can be used to further rank the documents. So centrality measures or centrality measures in case of graph, centrality measures are most important to evaluate the performance of the retrieved documents. So degree, first of all, degree means the total number of vertices incident to a vertex. Uh, Firstly, I will try to explain the things that at this particular time, your semantic graph, you are having query, you are having the documents, and at this particular point of time, you have constructed, we are assuming that you have constructed semantic graph. You know that how to construct the semantic graph. Once the semantic graph is constructed for the document, then we can apply these statistical measures, centrality measures, to evaluate the query terms, their relationship, and on the basis of those documents, how document is related with the query. So degree is also one of the centrality measures in the graph. The total number of vertices incident to vertex V means the degree of a vertex is denoted by degree of V, and the degree of any vertex means how many other nodes are connected, how many incoming and outgoing links are there. That is what we call degree. Out degree, how many outgoing nodes are there, how outgoing linkages are there. So in a direct graph, the number of edges going out from vertex V to other vertices, that is called out degree. In contrast, in degree, how many number of edges are coming to a particular node, incoming nodes, they are basically, that number is collectively known as in degree of that particular node. Weighted degree, if these edges which are coming to particular or going from this particular node to other nodes, if they are having some weight, they are known as weighted degree, weighted in degree, or weighted out degree. Now, authority and hub. This measure is the amount that a node of vertex scores is known as authority score. Authority and hub score is basically considered when we talk about the web-based information retrieval, when one web page is linked with many other web pages, or many other web pages are linked with that particular page, then the authority of that particular page is will be very high. The hub score of a node is proportional to the sum of authorities of nodes pointing to it. Page rank is basically PageRank is a measure denoting the importance of each node within the graph based on the number of incoming relationship and the importance of corresponding source node. And PageRank is used by Google search engine as well. Then clustering coefficient is also centrality based measure, graphical based measure. So clustering coefficient is a method to measure the network's transitivity. And what transitivity says that if a node A is related to node B and node B is related to C, then definitely there is a relationship between the node A and C as well. This is what we call transitivity relationship. And clustering coefficient marks such relationship as the probability that A is also directly linked with the C. Degree centrality. Centrality is a function to denote the significance of a node in the graph. The degree centrality is the number of neighbors of a given node. A given node can be more central than other nodes even if it has a smaller degree. It might be possible that a particular node is having many neighbors in its surroundings. That is, how many number of nodes are surrounding this node. That is what we call degree centrality. Closeness centrality is basically a measure that reflects how close to all other a given node is. Means if you find the distance of that particular node to other nodes, then for how many nodes it is close to other nodes. Betweenness centrality came into picture when we find a path from one node to another node, and how many times that particular node is coming in the path, in between the path. That is known as its betweenness centrality. Eigenvector centrality is a measure of the node's influence in a network or a graph. High eigenvector score means that the node is connected to many such nodes which themselves have the high score. Means if a person is influential because it is having many people influential in its network only. So similar with this concept with eigenvector centrality also conveys the same thing. If a particular node is influential itself, then it is surrounded by the other influential nodes as well. Eccentricity, it is defined as the maximum distance of one vertex from the other vertex, maximum distance between a vertex to all other vertices considered as a eccentricity for that particular vertex. So these were some of the graph theoretical measures, which in themselves only they are very powerful to compute the performance of any semantic graph, or very helpful to retrieve for text mining purposes or information retrieval purposes. I also took these measures into consideration when I experimented uh, for text summarization and uh, keywords extraction using semantic graphs, and I got good comparable results from earlier benchmark uh, algorithms. Now it's time for questions. As of now, we have discussed for the what is the evolution and lexicographical similarity. Then what are the challenges with the IR, Hindi IR, and then semantic graphs, how the semantic relationships are helpful, its architecture, performance, rank, and etc. So on the basis of that, I framed few questions, and I would like to ask all of the participants these questions. Very first question, what is the main limitation of traditional keyword-based information retrieval system? I'm again repeating the question. What is the main limitation of traditional keyword-based information retrieval? It means that is lexicographical based information retrieval system. And the options you are having, they require large data sets, they fail to capture semantic meaning base, they use machine learning algorithms, they retrieve documents too quickly. Yes, anyone can respond to this question.
Dr. Manju, they have written the answer in the chat, and all are correct.
All right. Okay, fine, ma'am. Thank you so much. So this is the right answer. They fail to capture semantic meaning of the queries. The next question is, which component converts textual knowledge into the subject predicate object format in semantic graph construction? Repeating the question, which component converts textual knowledge into subject predicate object format in semantic graph construction? Tokenization, semantic triplet formation, document indexing, or stop word removal? As I'm on slideshow mode, I'm not able to see the chat box. If anybody from organizing team can help with the chat box answers. All right, so the correct answer for this is semantic triplet formation because combining subject, predicate, and object, that is part of, we have already discussed it in semantic architecture, semantic based IR architecture, that was graph based IR. So it was related to semantic triplet. This particular formation is known as semantic triplet formation. The next question is, which metric measures how many of the retrieved documents are actually relevant? Which metric measures how many of the retrieved documents are actually relevant? Precision, or F1 score, or accuracy? Okay, let me check for the. But if I go with the answers on the chat box, then I'll definitely lose my slideshow. No problems. This was the question, and the precision is correct answer for, because how many of the retrieved documents are actually relevant? That is known as precision. Next question is, which stage of semantic graph construction identifies entities such as people, organization, and locations? So all these are entities, people, organizations, and locations. So that will be recognized by entity recognition. That's why the answer is B. The last question for this particular is, what is the primary role of ontology in semantic information retrieval? What is the primary role of ontology in semantic information retrieval? Defining a structured relationship between concepts, compressing the document, eliminating irrelevant documents, or storing text data. So the first answer is correct in this, defining structured relationships between the concepts. So ontologies are basically used to establish a structured and semantic relationship among the terms. Now, continuing with our discussion on on semantic graphs. So every aspect, every particular concept is having its own limitations as well. So semantic graphs as well. Semantic graph itself is also having some limitations. And what are these limitations? Let's discuss that. Semantic graphs depends on manually or semi-automatically created knowledge resources. WordNet is also created, and it is having some limitations. Uh, when we were making use of WordNet, we also suggested few of the corrections for WordNet, a few of more incorporations for WordNet as well. So in none of the time you cannot say that the tool itself is a complete, because NLP is very, very vast. Any natural language is very, very vast. So these resources often have limited coverage, especially for Hindi and other low resource, because they are in like growing age. There's these resources for India, they are still in growing phase. So some new terms or domain specific words may not exist in the semantic graph. For example, I told you about the physician and doctors. It might be in the WordNet, it is not related at all. Physician and doctor, are these related? We have to check. Solution through neural network. So how these limitations which we discussed here, that is how we overcome with this. So neural models, neural network based information retrieval models ensures to overcome from this limitation. So they learn semantic relationships automatically from large text or corpora. In case of ontologies, what happens once you have constructed the graph, means you have constructed and the researchers are making use of it. But as I discussed this thing, that natural language is very, very vast. You cannot say any time that this is the complete thing. So are the semantic graphs or any semantic based IR is capable learn in itself if some new relationship occurs in the document? So no, the answer is no. So to overcome from this particular limitations, neural network models came into picture and they tried to find the implicit relationships as well. And they try to establish those relationships. So few examples like BERT, sentence transformer, sentence passage retrievals are few tools which are taking care of these things. Semantic based IR as well as dynamically they are establishing relationship between the new terms of the document. They can capture semantic similarity even without explicit knowledge of the graphs. The another problem with semantic graphs are difficulty handling the context. Yes, as of now, we haven't talked much about the context. So that is the limitation about for semantic IR and hence for semantic graph as well. So they usually represent a static relationship between concepts. Bank, the possible meaning of bank can be financial or a river bank. Semantic graph alone may not always resolve the contextual meaning. Might be it needs something more. But if I say only one word, bank, cannot resolve this particular, uh, or if I do not much specify anything, uh, then it cannot resolve this particular ambiguity. Solution is again through neural models because neural models establish contextual embeddings, meaning the representation of a word depends on its context. If the word bank is somewhere in the sentence is related to finance, means it is conveying bank as a financial institution. Otherwise, it can be a so context by through neural models establishes contextual embeddings, and through contextual embeddings, the exact meaning of that particular uh, term can be taken care of. So different embeddings can be generated by neural models. Third problem is manual construction and maintenance. In semantic graph, every time if you find new term, you have to incorporate into semantic graph by in a semi-automatic manner or manually. So building semantic graph often requires expert knowledge, notations, ontology design. This process is time consuming and expensive as well. It is not worth every time incorporating the words. Solution of this, the neural IR models can learn semantic relationships automatically from large data sets. They are dynamically enhancing the semantic relationships between the document terms. Fourth problem is limited scalability. Yes, once you are constructed for any particular, you cannot scale for further. Large semantic graphs can become computationally expensive when the number of nodes increases. Graph traversals become expensive. So that is also a limitation for semantic graphs, and it can be overcome through neural retrieval models as vector representations in infinity similarity searches there. Embedding similarity cosine, we will discuss it in neural network architecture. These methods scale well for large document collections. The last problem is difficulty handling implicit semantics. Yes, explicit relationship is already there in semantic graphs, but are the implicit relationships there? For example, teacher teaches a students. So is the relation, what is the relationship between a teacher and the student? That is of teaching. So is this particular relationship is captured by the semantic graphs explicitly? If it is not captured by the graphs explicitly, as your IR model is capable enough to establish implicit relationship as well. So that is possible using the that capture latent semantic relationships from the data. For example, doctor and physician. Doctor is also almost equal to, we can also use these terms vice versa as well. We always call doctor, not specifically physician, but we can also call physician as well, if the relationship is not explicitly defined. Now, as we talked that semantic graphs are there, they have some limitations, and also discuss that these limitations can be addressed by using the neural networks. So one of the approach is, can we combine semantic graph and neural network models? So yes, we can combine, and many of the existing systems are also making use of these. Many chatbots like Alexa, Siri, all these are also making use of hybrid solutions, taking semantic graphs as well as neural embeddings into the consideration. So instead of choosing only semantic graph or neural IR, modern systems combine both, and this approach is called as neurosymbolic information retrieval. And the hierarchy, you can visualize it as semantic graph added with the neural embeddings are in resultant we can have semantic retrievals, and they provide structured knowledge representation and text aware semantic understandings. This is the architecture for hybrid system. Hybrid means neurosymbolic or neurosemantic hybrid semantic retrieval pipeline. So here, if I start from the left side of this architecture, I can see we can see that there is an input again in form of PDF, web documents, or any HTML, Word documents, anything. These documents are again basically this particular architecture is having four different components. One is the input, last one is the output generation. These between these two, there are two processing pipelines. One is completely dedicated to the semantic aspect, semantic graph based, and another is conveying neural embedding representation branch. So here in this particular component, symbolic knowledge graph branch, the this is as similar as we have discussed in our semantic graph IR architecture. We ingested means we uploaded, we loaded the documents, we pre-processed the document, we recognized the entities, we extracted the relationships between the entities, and then entities are linked with those relations, and ontologies are managed through schema, classes, and their properties of entities. So this is the knowledge graph is constructed. This is the constructed graph here. And then the triple store, wherein what we have done, the subject, predicate, and object, that relationship also we have established here. In this lower component, we are taking care of neural embedding representation, wherein the same textual data means the input data, raw data is considered, document is taken care of. The document is represented here, it is represented in form of neural network based embedding models. And then a vector is created with the numerical values, similarity values among these things. Now, after considering these two independent constructions, what we are doing, we are combining both of these as a hybrid semantic solution. Then the user is providing a query as an input query, and here after the embeddings are constructed, vector similarity is also provided. Then the answer is generated by RAG, that is retrieval augmented generation. The answer will be generated as per query. Then ranking will be done, and again the ranked answers will be generated. This is how the neurosymbolic hybrid semantic retrieval pipeline works over the semantic graph and combining the uh, embeddings, neural embeddings as well. Now, for this architecture, we are also taking one example. Suppose user has given an input, प्रधानमंत्री नरेंद्र मोदी ने नई दिल्ली में संसद के नए सत्र का उद्घाटन किया. I am repeating this sentence. प्रधानमंत्री मोदी ने नई संसद के नए सत्र का उद्घाटन किया. This is the raw text. What user is asking, दिल्ली में पीएम ने क्या शुरू किया? This is the question. दिल्ली में पीएम ने क्या शुरू किया? And the final answer is प्रधानमंत्री नरेंद्र मोदी ने नई दिल्ली में नए सत्र की शुरुआत. This kind of natural language answer means when human interacts with each other, they also give similar kind of. This kind of answer is generated by retrieval communication. We have discussed in this architecture as well. Now, how this particular example is processed through this architecture, we are showing in this slide here. So, input is taking संसद का नई दिल्ली में नई सत्र की शुरुआत की. This is the sentence taken as an input. Now, the semantic graph is constructed after these pre-processing, anti-recognition, relation extraction, and all that process. It has gone, the sentences has gone through all these pre-processing stages and then constructed this knowledge graph. And you can see Narendra Modi and Sansad Ka Satra. These are two entities and they are established with this relation Udghatan Kiya. Means Narendra Modi, Sansad Ka Satra, both are sharing the relationship Udghatan Kiya. Similarly, Sansad Ka Satra. Sansad मतलब संसद का सत्र कहाँ स्थित है? संसद में स्थित है. तो between संसद and संसद का सत्र there is a relationship was located और स्थित है. Similar kind of relationship is shared by संसद and नई दिल्ली. Means संसद कहाँ स्थित है, कहाँ located है? That is in Nai Delhi. So this kind of semantic graph is constructed after this much of pre-processing through this semantic knowledge graph branch. Then the triplets are also extracted. And another component that is based on neural embeddings representation, that is again considering the same input text. संसद की संसद में नई दिल्ली में संसद के नए सत्र की शुरुआत की. The same sentence is taken by this component as well. Then for this, neural network based embedding models are created and neural embeddings are generated. This is a vector basically showing the semantic relationship in numerical form between the terms, and this is the final vector we are having. This retrieval and answer generation, again it is both components are going through the hybrid semantic search engine. Query is given by the user. प्रधानमंत्री नरेंद्र मोदी ने नई दिल्ली में संसद के नए सत्र की शुरुआत की. And the query is दिल्ली में पीएम ने क्या शुरू किया. Here, vector-based embeddings are basically also establishing relationship is शुरू किया, उद्घाटन किया. And these relationships are basically are considered when the answer is generated by the RAG, or you can say retrieval augmented generation. So answer is generated and then those answers will be ranked because multiple answers, multiple documents can be retrieved, multiple answers can be retrieved, and then ranked answer will be given to us. This is how the hybrid symbolic hybrid semantic retrieval pipeline is processing that particular input text. Now again, as the semantic graphs were having some limitation, so the neuro-symbolic or hybrid architecture is also having its own limitations as well. So one of the limitations definitely because there is a mismatch between the GPU and CPU. Neural models are basically, they have good performance when they run on GPUs, while the semantic graphs can work on CPUs as well. So there is a two different kind of processors required. So if we do not take care of this thing, the response time will be delayed. Incompleteness, AI misses facts not in the graph. Graphs are static. The real world is dynamic. Yes, once the graph is constructed, and only the terms which are represented or the concept represented by the graph, that will be considered, nothing else. Complexity, harder to build and maintain, requires symbol grounding and expert defined schemas, expert knowledge, as discussed earlier as well, because to construct a complete ontology or semantic graph, and linguistic experts' opinion is very needed. Cost more expensive to run because two models are running at a time and constructing the hybrid model. So dual processing requires more memory and computational power. Now I have a few questions here. What is the main advantage of hybrid neurosymbolic retrieval systems? What is the main advantage of hybrid neurosymbolic retrieval systems over semantic graph, in fact? So the first is they reduce computational complexity. They combine symbolic reasoning with neural semantic understanding. They eliminate knowledge graphs. They rely only on keyword search. And the correct answer for here is they combine symbolic reasoning with neural semantic understanding. That is how they create the hybrid. Next question, which component converts textual knowledge into the subject predicate object format? I think I have already taken this question in earlier part, semantic triplet formation. Now, as we have discussed few limitations, we discussed few limitations of hybrid architecture, hybrid neural network as well. So, some of the limitations can be overcome by using graph neural networks. So, what are the limitations of hybrid architecture and how, just a moment, I think, and how it is overcome by graph neural networks? Let's discuss that. So, limitation of hybrid architecture, graph reasoning often uses fixed rules. GNN learns graph relationships automatically. As in case of hybrid architecture, we are having two components. One is semantic graph and another is having conceptual embeddings. But in case of semantic graphs, we are having fixed rules because we are having fixed connections, fixed linkages between this between the nodes. So since the linkages are fixed, they cannot be dynamically changed. So the reasoning is also limited as well. In case of graph neural networks, it ensures that it will automatically learn the new terms and linkages between them in the document. What are the terms which are not specified in semantic graphs but in the document? Then there might be possible they are not implicitly linked in semantic graph, but they are having some explicit relationship. So hybrid neural networks are not capable enough to establish those relationship, and that's why compromising through the performance of the retrieval performance. So graph neural network resolves this automatically establishing relationship through some criteria. The second limitation is hard to capture complex multi-hoop relationships. Multi-hoop means with multiple layers, the relationship with multiple layers. So GN propagates information through the multiple layers. This will be discussed in the GN architecture. How multiple layers, what is the function of multiple layers, and how they are enhancing performance of retrieval as well. The third limitation of hybrid architecture is limited ability to learn context from neighbors. Yes, in case of graph neural networks, neighbor nodes and neighbors and the linkages at global level in the semantic graph are very much considered through multiple layers. This is not case with the hybrid architecture. Certainly, when the different kind of relationships are considered more and more, then the retrieval performance also becomes much more. So the GNN graph-based neural networks gives higher relevant results in comparison to hybrid neural networks. Difficult to model global graph structure, learns representation from entire graph. This also GNN also have one layer where it considers a global relation terms in the semantic graph, while this is not the case with the uh, semantic graph or hybrid neural network based uh, model. Static knowledge graph reasoning. The knowledge graph definitely already considered this in first limitation as well. That once the graph is constructed, that graph can, whatever that graph can perform the reasoning, only we are limited, we can rely on that only. But GNN updates node representations dynamically because it establishes the relationship between the new terms in the document, which is not presented in semantic graph, but having some explicit relationship. GNN discovers those relationships and takes care while retrieving the document as well. So in all the cases, GNN is performing better as far as the retrieval efficiency is considered. Now let's discuss how GNN or graph neural network functions basically and how it gives us better retrieval results. So again, there's input data, unstructured data is there, PDFs, raw text, web pages, anything, document can be anything, unstructured data is there. Then graphs are considered, initial node embeddings. Here what we are doing, we are on the basis of word embeddings, we are trying to create the graph here. Now, this was stage one, stage two. Now, coming to the center part of this architecture, that is a stage three. This is the significant, most significant part of this, where the whole efficiency is found of GNN or graph-based neural network. Here, what, as we discussed in earlier slide, that the processing of GNN pass through the multiple layers. And what is the use of layers and what is the function of these multiple layers is there are three different kind of neighboring things are there. First of all, if there is some node, and it will be taken care with its immediate neighbors, then the second layer will be taken care of immediate neighbors means the second layer, one node's immediate neighbors and immediate neighbors. That this is the second layer, how it is working. And third layer is working on the neighboring, taking into the consideration the graph as a globally. How globally this term is connected with the neighboring nodes. So these are different layered architecture is there. And inside this particular architecture, in layer one, all the means the features will be aggregated, means one node A is there and all the neighboring nodes features will be aggregated and given or assigned numerical terms. This is what we call neighborhood aggregation. The same thing is considered for GNN layer 2 as well, wherein neighbor is considered instead of immediate neighbors are considered and their features are considered. And this is what we do in GNN layer 2. Again, for the third layer, what we do, layer K, which takes care on the global, in the global scenario, it takes care of the neighboring nodes, how they are. And again, the functioning will be the same. All the time, the features will be aggregated and an aggregated score will be assigned to each and every node into consideration. So this is how it is considered, the nodes, their relationship in global form. And after that, after considering all these layers, after the graph is gone through all these layers, final enriched embeddings are constructed. And after that, nodes have learned context from the entire graph. The last stage, stage 5, that is output prediction, GNN resolution, link prediction. If what is the relationship between the terms like Modi and inaugurated, or Modi and parliament, that is inaugurated, the relationship is not. So link predictions will be there. Node classification, whether a particular node or entity is coming under which class or which category. For example, Sansad is coming, or it's an instance organization. Query based answer. Then after all this arrangement. After considering all this, the query-based answer will be extracted. So retrieval augmented generation that will generate the answer as per the user's language. RAG with contextual knowledge generates precise, logically verified answer. So this is how these three different architectures. We discussed three different architecture. One was completely the core semantic graph-based architecture, which was having its own limitations, which was not considering context. Then the enhanced version of hybrid model by taking care of a neural network into consideration and combining it with semantic graphs, we found that we have achieved the context-based retrieval. Further, there were some limitations of hybrid architecture as well, which was overcome by graph neural network architecture. The major limitation of hybrid neural semantic or symbolic architecture was it was having a static semantic graph. Once graph is constructed, you cannot reason beyond that particular graph. So uh, but in natural language there can be different new terms, new relationships between terms. So in many of the cases these kind of relationships are not established in the already constructed graphs. So GNN overcomes from that limitation and it dynamically establishes the terms as per the document terms. So this was the architecture. It gives us improved results in in case of semantic IR. Key advantages of graph neural networks in semantic retrieval: learning semantic relationships automatically, as we discussed that not only the implicit relationship but explicit relationships are also established by using graph capturing multi-hop graph reasoning, integrating symbolic knowledge with deep learning, uh, improving contextual understandings. So, whatever was the features of hybrid architecture that is already incorporated in GNN as well. Apart from that, it is also taking care of establishing the relationship between the as per the document requirement. Now, on the basis of this discussion, the question is, what is the main benefit of using graph neural networks in semantic information retrieval? Uh, what is the main benefit of using semantic graph neural
Sorry to
network?
interrupt, Dr. Manju. You can take a break
Sure,
of 5
ma'am.
minutes. You would like to move around, or the participants may like to move around. It's almost 1.5 hours you are speaking.
As you
Yeah,
say.
yeah. 5 minutes
As you
break
say,
is, I
ma'am.
think, desired for the participants.
Sure, ma'am.
5 minutes
Sure,
break
ma'am. We can have a
will
5
come
break.
after 5 minutes. Yeah.
All right, ma'am.
Okay.
Thank
Have
you.
a break,
Thank
please.
you.
Have a water and move around, please.
Sure.
Thank you so much.
Thank you.
It's very nice going on.
Thank you so much, ma'am. I hope the students
Yes.
are
Of course,
also
they
getting
must be,
something
or
to.
otherwise they will learn later also. They're at their own pace.
Thank you. Sure, ma'am. Thank you so much.
Professor Manju, we can start.
Yes, ma'am, we can start. I'm here only. Okay, so my screen is visible now. Please respond. My screen is visible to all of you.
Yes, it is visible. Audible too.
It's visible. All right, ma'am. So, based on the GNN architecture, I'm having few questions. What is the main using graph neural networks in semantic information retrieval? What is the main benefit? They remove the need for graphs, learn semantic relationships directly from graph structures. They only store documents. They reduce document size. So the answer is semantic relationships directly from the graph structures. Next is semantic IR languages, and definitely the answer is B, because linguistic resources and data sets are very limited available for low source languages. The last question for this session is, which technology is most promising for learning complex relationships in semantic graphs? Decision tree, graph neural networks, naive Bayes, and linear regression. As per our discussion, today's discussion, GNN, that is graph neural networks, are most promising and emerging techniques. Now, we discussed about how to semantic graphs are. But are there any graph visualization tools available? So yes, if you are having documents and the graph visualization tools are available which can create graphs for you, right? So Gephi is the most widely and open source tool. Apart from that, YE Graph Editor, GraphViz, and Cytoscope. Among all these, I myself have used for my experiment for text summarization and keyword extraction. YEP also I have used to some extent, and other tools are available online as well. So important tools used in research is actually for Indian languages and Hindi as well. Hindi, yes, relationship, NDIC, NLP for Hindi text processing, SPACE, that is entity for extraction, Wikidata and Wikipedia is knowledge base or to create knowledge graph linkages. Knowledge graphs, that also I have used. NetworkX for graphic analysis, IndiqueBird and MBird. MBird is basically, IndiqueBird is used for Indian languages. IndiqueBird as well as MBird, both are used for Indian languages for constructing semantic embeddings. So these tools can also make use for your experiments. Then, as per our today's discussions, what are the future directions, research directions still available to explore further? That is GNN. First of all, GNN. GNN is basically an emerging techniques. It is still in growing phase. There is a lot of scope where, and there are many applications wherein GNN can be explored to increase the performance of retrieved results as well. Similarly, cross-lingual semantic IR, where the query is given extracted in another language, that is still underexplored information retrieval research area. That is also, there are a lot of scope to be explored from one Indian language to another Indian language, or from Hindi to English, or languages. Similarly, knowledge graph expansions. Yes, knowledge graphs and semantic graphs, they both are related, but at the same time, they can be knowledge graphs and semantic graphs using further models, embedding models were transformed to explore further or to enhance the performance, retrieve performance. Similarly, clinical IR, in this, what happens? AI-based systems, what happens? Your model gives you results, but how it doesn't give you the reason behind the results. So information-based AI systems are very much needed. Whatever answer is given for the query, why that answer is given, if your systems are able to provide this reasoning as well, that will be very, very helpful, and that will create further trust for that particular AI systems. So these are a few research direction wherein a lot of scope to further work. Now, after today's session, what we have learned, so information, so graph-based IR enables and system capture concept, relationship, and actual meanings. Knowledge graphs and graph neural networks we have discussed. Cross-lingual, multilingual approaches and other low resource languages. Future of art lies in neuro or explainable AI, enabling accurate, transparent, and intelligent search systems. So these were some key points of today's discussion. Apart from that, some of the institutions which are particularly working on Indian languages, they are IIT Bombay. Very first institution which come into my mind is IIT Bombay itself, wherein CFILT is a center for Indian language technology. For Indian languages, lot of work is going on there since year 2000, which I'm observing. WordNet is also Hindi WordNet and other Indian language WordNets are also developed only. Then IIT Madras is also doing a lot of hard work over here. AI for Bharat, large data set, multilingual models for Indian languages they have developed. Triple IT Hyderabad, where Language Technology Research Center, wherein you can have multiple research based resources are there, multiple data sets for different domains, for different purposes, different applications are available. Machine translation and NLP research, they're working hard for here. IIT Delhi, especially in analytics. IIT Kharagpur, NLP and language technologies. ISC Bangalore, AI and machine learning, computational linguistic. CDEC Pune and CDEC Noida also working hard over it. TDAEL program. CDEC is working for government initiative, especially for Indian languages. AI for Bharat Consortium, models and data for all 22 Indian languages are available with. Apart from that, work of some of the people are also working in Jadavpur University in Vanastali with Professor Nishit Joshi, working on cross lingual and machine. They are also working a lot. The team is also working for Indian languages as well. Government initiatives is supporting Indian language research because all of us, we know, we are very much known to Academy mission. Every time you can see posts on LinkedIn, their work, so these are basically government of India's initiatives, technology development for Indian language by MIT, and Bhashini mission, AI for Bharat National Language mission. All these are run by the government in government Indian languages and Hindi, for, especially for research. These are the references which I have used and you also use Indian languages in Hindi as well. Some of the books are there and some of the tools reference are also there for us. This is my mail ID. If something related queries you are having, you can also put your mail on this, and you can also drop a mail to me as well. You can also have queries. You can ask queries here as well right now. So that's all from my side. And one more thing which I like to share here, why I chose the particular session. I said also in Hindi. Apart from that, what I felt as a researcher, what I think, whenever we submit proposals proposals to government agencies for projects and all to DST or some other agencies, they prefer if you work or contribute something for Indian languages, then definitely to be accepted for that particular proposal. So there are ways aspects back to the society, whatever we are learning. If we really our country, that will be very, very helpful for all of us. Thank you so much from my side. I would love to answer all queries if the participants have. Somebody is having question here, ma'am. We have some question here. So I think as of now, I'm not taking any.
Thank you so much, Professor Manju. It's really very insightful.
Thank you so much, ma'am.
Participants must
It was an
lots
honor.
of takeaways.
I think so. I wish so that participant has learned something and further explore these kind of topics as well.
Yes. The answer of this question is, do we have GNN and IR lab sessions? Of course, yes, on GNN, but not on IR because it's kind of an overlapping thing. We are doing NLP only in this course. Later, we'll do a course on IR. Then we'll have the hands-on on IR. Thank you so much, everyone. So now we have,
thank you so much for
on text classification. That is kind of a amalgam of both theory plus hands-on.
Okay. So shall I take a lead, ma'am?
Thank you so much.
No? Thank you so much, ma'am. Thank you. Thank you. Thank you much.
So participants, a specific break of 10 minutes just before this one. If you would like to take, otherwise we'll continue. Please write on chat. Would you like to take a break or should we continue? It's hand-on session using Python. Come prepared with your laptops.